Haloform reaction. This is today's lesson. What is haloform? Let's see. This is methane when 3 hydrogen atoms of methane are replaced by 3 halogen atoms, then we get CH(X3), which is known as haloform. If X is fluorine, then this is CHF3, fluoroform. If it is chlorine, then CHCl3, chloroform. If it is bromine, then CHBr3, bromoform. If it is iodine, then CHI3, which is iodoform. So fluoroform, chloroform, bromoform and iodoform. These compounds are known as haloforms. Trihalogenomethane is a haloform. Haloform reaction involves carbonyl compounds, specific carbonyl compounds. In this lesson, we are going to learn carbonyl compounds and eligibility, reaction and definition of haloform reaction, mechanism of haloform reaction, ethanol, secondary alcohol undergo haloform reaction, but acyl chloride, ethanamide, ethyl acetate ester, acetic anhydride, these compounds do not undergo haloform reaction. In this lesson, we are going to learn the reason behind this. So, let's go to the detail. The first point is carbonyl compounds and eligibility. That is, all carbonyl compounds do not undergo haloform reaction. Some specific compounds undergo haloform reaction. This is eligibility of carbonyl compounds. Let's see what are carbonyl compounds. CO group, which is known as carbonyl group. When both the hands are satisfied with hydrogen or alkyl group or aryl group. Here hydrogen or alkyl group or aryl group, then the compound formed will be carbonyl compound. Let's see some examples of carbonyl compounds. This is formaldehyde, this is acetaldehyde, this is propanone or dimethyl ketone. This is ethyl methyl ketone. This is phenyl methyl ketone. These compounds are examples of carbonyl compounds. Here we see this is carbonyl compound with CH3CO group, which is known as methyl carbonyl group. But this carbonyl compound doesn't contain methyl carbonyl group. This is another carbonyl compound, propanone, which contains methyl carbonyl group. This compound contains methyl carbonyl group. This carbonyl compound contains methyl carbonyl group. But this one, formaldehyde, doesn't contain methyl carbonyl group. This is the meta of eligibility. That is, carbonyl compounds with methyl carbonyl group undergo a haloform reaction. Another compound, benzaldehyde, that doesn't contain methyl carbonyl group. So this carbonyl compound doesn't undergo haloform reaction as well. Simply, carbonyl compounds with methyl carbonyl group undergo haloform reaction. This is eligibility of carbonyl compounds to undergo haloform reaction. Only the point, carbonyl compounds with methyl carbonyl group undergoes haloform reaction. Let's move on to the next point. Reaction and definition of haloform reaction. Let's write a general compound, carbonyl compound with methyl carbonyl group, that is CH3COR. Carbonyl compound with methyl carbonyl group. Here A may be hydrogen, methyl group, ethyl group, phenyl group, etc. When this compound, carbonyl compound with methyl carbonyl group, is treated with halogen in presence of concentrated sodium hydroxide and the reaction is heated, then this group, methyl group, turns into haloform and this portion turns into sodium salt of carboxylic acid. Then sodium halide and water are produced as byproduct. That is, carbonyl compound with methyl carbonyl group is treated with halogen in presence of concentrated sodium hydroxide. Then haloform is produced. This reaction is known as haloform reaction. Here X may be chlorine, bromine and iodine. X here cannot be fluorine. Fluorine doesn't undergo haloform reaction because we know fluorine is highly reactive element than other halogens like chlorine, bromine and iodine. This is extremely reactive halogen. That is why halogen, that is fluorine, doesn't undergo this reaction, haloform reaction. Definition of haloform reaction is carbonyl compounds containing methyl carbonyl group is treated with halogen except fluorine in presence of concentrated sodium hydroxide. On heating, carbonyl compounds produce halogen and sodium salt of carboxylic acid. This reaction is known as haloform reaction. Chlorine, bromine and iodine undergo haloform reaction, but fluorine cannot undergo haloform reaction and Fluoroform cannot be produced because of its higher reactivity. Let's write a reaction as example. If it is treated with bromine in presence of concentrated sodium hydroxide and the reaction is heated, then this portion turns into bromoform CHBr3 and this portion turns into sodium salt of carboxylic acid, that is benzoic acid, and then sodium benzoate, and then sodium bromide and water are formed as byproduct. So here the carbonyl compound containing methyl carbonyl group undergoes haloform reaction and here bromoform is produced. Let's move on to the next point. Now the point is mechanism of haloform reaction. Let's see step by step. Step 1. Concentrated sodium hydroxide produces sodium ion and hydroxide ion. Step 2. Carbonyl compound with methyl carbonyl group reacts with this hydroxide ion. Here hydroxide ion attacks. We can write this compound as this. Here carbonyl group gets polarized. Electronegativity of oxygen is 3.5, carbon is 2.5. So pi bonded electrons move towards oxygen and this carbon gets positively charged and oxygen gets negatively charged. Because of this positive charge, these carbon hydrogen covalently bonded electrons shift to carbon-carbon bond to form carbon-carbon double bond here, and at that time this hydrogen is freed as proton which combines with this hydroxide ion to form water, and another entity is formed. This is carbon. Here now two hydrogen atoms. This hydrogen is freed as proton and combines with what? Hydroxide ion to form water. Now this hydrogen contains two hydrogen atoms and here carbon-carbon single bond turns into carbon-carbon double bond. Here carbon, oxygen, negative charge. This is alkyl group. This entity reacts with halogen. This halogen undergoes heterolytic fission to form halogen cation and halide ion. This is elementary molecule. Nevertheless, it undergoes heterolytic fission. The reason is that when this halogen approaches this carbon-carbon double bond, then there is created electrons repulsion. As a result, these covalently bonded electrons move towards this halogen because of this repulsion, and as a result this halogen turns into halogen cation and this halogen turns into halide ion. That is, halogen undergoes a heterolytic fission. As carbon-carbon double bond is electronically dense place, that is why this halogen cation approaches this carbon-carbon double bond. At one stage, this halogen combines with this carbon with the pi bonded electrons, and at that time these electrons turns into covalent bond again. Then we get carbon, hydrogen, hydrogen, here halogen. This halogen combines with this carbon. Again, this carbon-carbon single bond is formed. Carbonyl group, here alkyl group. In the same fashion, these two hydrogen atoms are replaced by halogen in this way. This is formed. Here we see this carbonyl group again gets polarized. It becomes negatively charged, it becomes positively charged. And here hydroxide ion is present in the solution that combines with this positively charged carbon, and then this group is eliminated as leaving group in this way. X3C minus, and here we get RCO. CO and OH combines with this carbon. Then we get this compound. This is carboxylic acid which donates proton to this ion to form CH(X3), and sodium salt of carboxylic acid is formed. In this way, haloform is produced. Ethanol and 2-hydroxypropane secondary alcohol. Though these compounds do not contain methyl carbonyl group, nevertheless these compounds undergo haloform reaction in this way. Suppose this one, ethanol reacting with halogen forms acetaldehyde, and hydrogen halide is formed as byproduct. So at the very beginning, this ethanol turns into carbonyl compound with methyl carbonyl group. That is why ethanol undergoes haloform reaction. Let's see about this one. Similarly, this alcohol, 2-hydroxypropane or secondary alcohol, reacting with halogen forms ketone, and hydrogen halide is formed as byproduct. Though this alcohol doesn't contain methyl carbonyl group, nevertheless it undergoes haloform reaction, because at the very outset of the reaction this alcohol produces carbonyl compound containing methyl carbonyl group. So these alcohols undergo haloform reaction, though it do not contain methyl carbonyl group. These compounds do not undergo haloform reaction. Let's see the reason. First one is formaldehyde that doesn't contain methyl carbonyl group. That is why it doesn't undergo haloform reaction. Second one is acyl chloride. It contains methyl carbonyl group. Nevertheless, it doesn't undergo haloform reaction because in this case chlorine acts as beta leaving group. In this way, methyl group turns into this group. Here chlorine is beta leaving group, then this group. That is why from this entity it is not formed. Rather, chlorine is eliminated as chloride ion. That is why it doesn't undergo haloform reaction. Another one, acetamide. Here electronegativity of chlorine is 3.0. Because of this higher electronegativity, it acts as beta leaving group, then this group. Similarly, electronegativity of nitrogen is 3.1. Because of this, amino group acts as beta leaving group. That is why from acetamide cannot be formed. Similarly, in this compound methyl carbonyl group is present, but this group acts as beta leaving group. That is why from this compound haloform is not produced. This is acetic anhydride that contains methyl carbonyl group, but it acts as beta leaving group. That is why from this compound haloform is not formed as well. This is all about haloform reaction. Number today. Thank you very much.